Good morning, students. So yesterday we learned colloids. What are the different types of colloids? So today we are going to learn how to prepare these colloids, preparation of colloids and how to purify the colloids. Still time there, we can learn some properties of colloids also. Okay. So preparations and purification, properties of colloidal solutions. Anyhow, few questions, not 5 questions, few questions from classification of colloids. So the first question is the first one. Gold salt, silver salt, sulfide salts. These are macromolecular colloids or multimolecular colloids or associated colloids. So the answer is gold salt, silver salt. Nothing but inorganic colloidal solutions. All inorganic salts are lyophobic salts. They are multimolecular colloids. Protein salt are cellulose like this given. Now it is a organic colloidal solution. All organic colloidal solutions are lyophilic colloids and they are macromolecular colloids. So proteins, gelatin like this given, gums given, answer is macromolecular colloidal solutions. Formation of micelle is associated colloid or multimolecular or macromolecular. Micelle is example for associated colloid or aggregated colloid. Now this micelle is a lyophilic, lyophobic, both lyophilic and lyophobic, nothing but hydrophilic, hydrophobic. So answer is both hydrophilic and hydrophobic in nature because multimolecular are lyophobic and macromolecular are lyophilic and associated colloids both lyophilic and lyophobic. Heads are hydrophilic and tails are hydrophobic. Yes or no? Tails are hydrophobic. And next question is in lyophilic and lyophobic, where more amount of electrolyte is required for coagulation. More amount of electrolyte is required for coagulation. So which is more stable, their coagulation is difficult, there more electrolyte is required. So answer is a lyophilic colloidal solution. Lyophilic colloidal solution. In lyophobic, the stability is based on which one is used as the stabilizer? Lyophobic colloids. Lyophobic colloids are less stable because of charge separation. So here what we are adding, lyophilic colloid is used as the stabilizer. I think yesterday's class, last one, this one only. Lyophilic colloid is used as stabilizer for lyophobic colloids. So lyophilic colloids are self-stabilizers. Why they are stabilizers, self-stabilizers? What is the reason for that stability? So what is the reason? Dispersion medium forms a protective layer. So due to the formation of protective dispersion medium layer, they are stable because more affinity between a dispersion phase and a dispersion medium. So the last question, what is the dispersion phase and dispersion medium in gel? In gels, because gels is a very important question and emulsion also important question. So what is the dispersion phase and dispersion medium? Dispersion phase is a liquid and dispersion medium is a solid. Liquid in solid type colloidal solution is called gel. So now how to prepare these colloidal solutions? Anyhow, lyophilic colloids, direct mixing we can prepare, no special methods because affinity is more. So due to the more affinity between dispersion phase and dispersion medium, by direct mixing of phase with medium, we can prepare that lyophilic colloids. So but lyophobic affinities are less, so we have to use some special methods. Now preparation of colloids, nothing but it is a preparation of lyophobic colloidal solutions, not lyophilic colloidal solutions. So how to prepare these lyophobic colloidal solutions? So what are the different preparation methods? Anyhow, classification, how many types of classifications we learned? First one based on physical state, 8 types colloidal solution. Second one based on nature of the dispersion medium, aerosols and hydrosols, alcosols, benzesols like this. And next based on mode of formation, multimolecular colloids, macromolecular colloids and associated colloids. And next based on affinities, lyophilic colloids, lyophobic colloids. Yes or no? These are types of colloidal solutions. Now preparation of lyophobic colloids because lyophilic by direct mixing. So how to prepare? What are the preparation methods? Preparation of colloidal solutions. So here one larger one given, nothing but there is its size is more than colloidal solution. Then to convert into colloid, what we should do? We have to bring that into colloidal size. Nothing but breaking is required. We have to break that. There is a dispersion. So dispersion method we are using. If the given particle size is very large compared to this colloidal size, then what we should use? A dispersion method, dissociation otherwise. Okay. And size of this particle is very small compared to this colloidal size. We should convert that into colloidal size. Then what we have to do? Condensation. Nothing but we should join all those particles. Here we have to break this large into colloidal size. So if very large given, we have to break that into colloidal size. Very small given, we should convert that into colloidal solution. Nothing but this we are converting into colloidal size by association, that we are converting into colloidal size by dissociation. So two methods we are using for the preparation of colloidal solutions. That is the dispersion method and also condensation method. So first one is the dispersion method. So in this dispersion method, we are converting that larger to colloidal size. Nothing but any precipitate is formed. That precipitate we are converting into colloidal solution. So for the conversion of larger to colloidal solution, there is a dispersion method. So what are the different types of dispersion method? The simple method is the grinding process. So first one is a grinding process. Grinding process means just grind that larger one to smaller one and add dispersion medium, then it gives a colloidal solution. So grinding process we can use for the preparation of colloidal solution from larger particles. Generally graphite colloidal solution, there is a printing ink that is prepared by using this grinding process. So grinding process means just larger one we are grinding to smaller particles, nothing but colloidal size. If dispersion medium is added to that, that gives a colloidal solution. So which is prepared by this grinding process? A common method, nothing but a common example, that is a graphite colloidal solution, nothing but printing ink. Printing ink is prepared by using grinding process. And second process, this is the important process, that is the peptization. Peptization. Preparation of proteins is called peptization, or proteins denaturation is called peptization. Like this given, peptides, peptide bonds are present in proteins. So there the bond is the peptide bond. Formation of peptide bond is called peptization. Like this given, right or wrong? Formation of peptide bond. Because in proteins, in biomolecules, in biology, you learn that between amino acids, peptide bond formation, there is the amide bond, long chains will form. They are only called proteins. Yes or no? So formation of peptide bond, there we are using peptide. Peptide bond is called peptization. Chance there to confuse. Most of the students will mark this option only. Formation of peptide bond is called peptization because the names are similar. But this peptization is different. It is in physical, that is in organic. So what is this peptization? Preparation of colloidal solution. So how to prepare this colloidal solution? In this peptization, don't confuse, that is a peptide bond, it is a peptization. Formation of peptide bond is not peptization. This is different. It is a colloidal solution preparation. So peptization is the characteristics of colloidal solution or preparation of colloidal solution or purification of colloidal solution. Like this given answer is it is the preparation of colloids. It is not the property of colloid. It is not the purification of colloid. So peptization, important method. What is this peptization given? First option is formation of peptide bond in proteins is called peptization. Purification of colloidal solution is called peptization, or it is the property of colloidal solution. It is the preparation method of colloidal solution. Given the correct answer is it is the preparation method of colloidal solution. So in this peptization, how to prepare that colloidal solution? First we are taking one freshly prepared any precipitate. We have to take one precipitate. For example, FeCl3, ferric chloride. It is treated with water. If it is treated with water, it gives some FeCl3 with water, FeOH thrice. This is ferric chloride, no? Ferric chloride. So what we are getting precipitate? Ferric hydroxide precipitate we are getting. Now it is a freshly prepared precipitate. Freshly prepared precipitate, that is a ferric hydroxide. Now it is precipitate. Precipitate and dispersion medium is there. Then that solution is a suspension. That solution is a suspension. But we are converting this into colloidal solution. So how to convert this into colloidal solution? First we are preparing one precipitate. Now it is a freshly prepared precipitate. To this precipitate, add any suitable electrolyte. To this we have to add any suitable electrolyte. Suitable electrolyte means what is that suitable? That must contains common ion. That must contains common ion. So suitable electrolyte with common ion. For example, here freshly prepared ferric hydroxide precipitate is there. To this we added FeCl3, ferric chloride. To this, nothing but here excess FeCl3 is taken. Definitely colloidal solution only will form. So FeCl3 is added. Now it is a suitable electrolyte. How can you say it is suitable electrolyte? Fe plus 3, Fe plus 3, Fe plus 3 is a common ion. Common ion is there. So add one suitable electrolyte. Freshly prepared one precipitate is given. To that we are adding one suitable electrolyte. Now here the electrolyte used is a FeCl3. Then what happens here? How this lyophobic colloidal solution will form? Lyophilic are neutral. Lyophobic are charged. They are positively charged or negatively charged. How this charge formation? Nothing but here origin of charge. Along with this preparation, I am explaining here origin of charge also. How this charge is developed. Now, here FeOH thrice. This is a precipitate. Okay. If suitable electrolyte, there is a FeCl3 is added. If FeCl3 added, common ion is there. Now this precipitate particle, breakdown of this precipitate takes place and each particle surrounded by common ion. What is that common ion? Fe plus 3. It forms one fixed layer. More interaction, then these common ions stick to that. So it forms one fixed layer, like this one layer formed. Okay, this is the first layer. This layer is a fixed layer. Common ion forms this fixed layer. Okay, now this is in solution. Precipitate is there. To that we added this FeCl3. Each precipitate particle that surrounded by Fe plus 3. Nothing but breakdown of that precipitate takes place. Common ions surrounded. Remaining ions, what are the remaining ions? Cl minus. All these Cl minus ions in this solution present. In solution, Cl minus ions. So this particle is a positively charged particle or negatively charged particle? Now it is surrounded by Fe plus 3. Nothing but it is a positively charged particle. Now it is a dispersion phase. This is a dispersion phase because particles are separated. Each precipitate particle is surrounded by common ion, that is the Fe plus 3. Okay. Now this like these particles are separated. Many particles are formed. These are colloidal-sized particles. Nothing but it is a dispersion phase. Remaining what solution is there? There is a dispersion medium. In this dispersion medium, Cl minus ions are there. Now this is called fixed layer. Like this one layer formed. Stick to that. That is a fixed layer. In solution, Cl minus moving. Nothing but it is a mobile layer. So this is a fixed layer. And this is mobile layer. Overall, this colloidal solution is positively charged or negatively charged given. This is a positive dispersion medium, the phase, and medium is a negatively charged. Overall, colloidal solution is a neutral. Always this colloidal solution is neutral. But here two types of colloidal solutions we are learning. Nothing but there is a positive colloid, negative colloid. This positive, negative based on charge on dispersion phase only. Overall solution whenever you observe, that is neutral because medium is negatively charged and phase is positively charged. What is the charge on this phase? That is called charge of the colloidal solution. So now it is positive colloid or negative colloid given. The answer is a positive colloid. So ferric hydroxide is a positive colloid because this is surrounded by Fe plus 3. So initially precipitate is there, that is complete Fe plus 3. Now to this one common ion FeCl3 is added. Each precipitate particle separates. Each particle surrounded by Fe plus 3 ions. Like this, all particles are separated. They changes to colloidal sized particles. They changes to colloidal sized particle because each precipitate separated changes to colloidal size. And Cl minus ions in this dispersion medium only. Now it is a colloidal solution. So the process of conversion of freshly precipitated or freshly prepared precipitate to colloidal solution by adding suitable electrolyte with common ion, by adding suitable electrolyte. That process name is a peptization. So peptization means how we are preparing this colloidal solution. One big precipitate given, that precipitate break down into colloidal solution. How to break down? Just add any suitable electrolyte. Then this separate into colloidal particles, and that particle surrounded by positive charge or negative charge. If it is surrounded by positive charge, that colloidal solution is a positive sol. Now ferric hydroxide sol is example for given answer is a positive sol. Okay, so this process name is a peptization process. Otherwise, for example, one more example. Now anyhow, what is the fixed layer given? In ferric hydroxide salt, the fixed layer is Fe plus 3 and the mobile layer is Cl minus. Now fixed layer, positive charge, this is the negative charge. Nothing but between these two potential difference is there. Positive layer, negative layer, potential difference. That potential difference is a zeta potential. This calculations complete in chemical engineering there. In that branch only, here just it is a, what is the potential? So what is the potential difference between fixed layer and mobile layer? That potential difference is called zeta potential. Okay. So what is zeta potential given? The potential difference between fixed layer and mobile layer. Nothing but all colloidal solutions but two layers, double layers. One is fixed layer, another is a mobile layer. What is the charge of the fixed layer? That is only charge of the colloidal solution. So now it is a positive charge. Better two more examples. Potassium iodide is added to silver nitrate. Anyhow, this is again a very important question, repeated question. Potassium iodide is added to silver nitrate. What is the reaction here? Potassium iodide is added to silver nitrate solution. Silver nitrate common name? In D and F block elements we learned common names, many common names. Answered or not? And in metallurgy also learned common names. So AgI plus KNO3. Okay, AgI and KNO3 is formed. AgI is a precipitate. AgI color white or yellow? Okay, this is a freshly prepared precipitate. Okay, freshly prepared precipitate. AgI precipitate formed. Now here just precipitate only formed. To this, if excess potassium iodide is added, nothing but suitable electrolyte is added. Now what happens? The precipitate is AgI. The precipitate is a AgI. Now to this excess potassium iodide added. This is the suitable electrolyte with common ion. Now this precipitate, breakdown of the precipitate takes place. Each particle surrounded by AgI, surrounded by K plus or I minus. What is the common ion? That we have to observe. So what is the common ion? I minus. So this one surrounded by I minus. Now this I minus forms a fixed layer. Yes or no? I minus fixed layer. And what is the remaining in this solution? K plus. Because excess potassium iodide added, remaining is a K plus. Nothing but just collect this silver iodide precipitate. To that add excess potassium iodide. Then like this, precipitate changes to colloidal solution. It is surrounded by I minus and K plus in solution. Now K plus forms a mobile layer and I minus a fixed layer. The potential difference between these two layers is called zeta potential. Anyhow, it is a negative sol or positive sol. Now this sol is a negative sol because it is surrounded by I minus. Instead of this, now excess AgNO3 is added. AgI precipitate formed, to that precipitate excess AgNO3 added. Now what happens? Collect this precipitate. AgI, to this we are adding excess AgNO3. Now which is the common ion? Ag plus is a common ion. Then it is surrounded by Ag plus. So Ag plus forms a fixed layer. Ag plus fixed layer formed. Now in this mobile layer, what is the remaining in mobile layer? NO3 minus. NO3 minus forms a mobile layer and Ag plus forms a fixed layer. Anyhow, what is this colloid? It is a positive colloid or negative colloid? Positive colloid. So the given question is a silver nitrate is treated with excess potassium iodide. The salt formed is, answer is a positive or negative. Excess potassium iodide, I minus surrounds. So that is a negative salt. Excess silver nitrate is treated with potassium iodide. The salt formed is given excess AgNO3. So the fixed layer is a Ag plus. Nothing but the answer is a positive sol. Or if excess potassium iodide is added to silver nitrate, then the mobile phase and fixed layers respectively, the mobile layer and fixed layers respectively given. Excess potassium iodide added. Definitely that is surrounded by I minus. Otherwise in rough paper you write the diagram, then you can identify surrounded by I minus, nothing but I minus forms a fixed layer and K plus forms a mobile layer. If excess AgNO3 is added to potassium iodide, the fixed and mobile layers respectively. Their question is a mobile and fixed respectively. Here question is a fixed and mobile layer. So what is the fixed layer here? Ag plus and mobile layer is a NO3 minus. Ferric hydroxide sol is a positive sol or negative sol. Given answer is a ferric hydroxide in the presence of FeCl3 surrounded by Fe plus 3. So hydroxide, very simple trick. Any hydroxide given, direct answer is a positive sol. All hydroxides, all hydrated oxides given they are metallic oxides given they are positive sols. Now this is the positive sol and negative sol. Anyhow, what we are doing? precipitate we are converting. And one more important example, that is a SnO2. SnO2 common name? Cassiterite, cerussite. Anyhow, tin stone is a better one, no? So cassiterite or cerussite? Cassiterite. SnO2. To this SnO2 we are adding sodium hydroxide. If sodium hydroxide is added to SnO2, sodium stannate. Na2SnO3 will form sodium stannate. Now sodium stannate is formed. This SnO2 colloidal solution formation surrounded by SnO3 2 minus. SnO3 2 minus. Then Na plus in a mobile phase. So the fixed phase is SnO3 2 minus, and mobile phase is because the product obtained is Na2SnO3. Then this SnO2 surrounded by SnO3 2 minus and Na plus. Na plus forms a mobile layer, SnO3 2 minus forms a fixed layer. Now this colloidal solution is negative sol or positive sol. This is also very important one. The SnO2 tin stone is treated with sodium hydroxide. The colloidal solution formed is given answer is a negative sol. This is a colloidal solution composition. SnO2 surrounded by SnO3 2 minus and Na plus forms a mobile layer. Okay. So anyhow, what we did here? Precipitate, converted to colloidal solution by adding suitable electrolyte. That process name is a peptization. So using peptization process, we can prepare colloidal solution. So in this dispersion, the first method is dispersion, means we are converting larger suspension to colloidal solution. Suspension to colloidal solution. The first process is a grinding process. This grinding process, just we have to grind, convert into colloidal size. This process is used for the preparation of printing ink. And second process, very important process, that is the peptization. Peptization means we are converting freshly prepared precipitate to colloidal solution by adding suitable electrolyte. Here different types of questions are there. What is the electrolyte used here? What is the charge of this colloidal solution? Excess this one used, what is the charge of the colloidal solution? Excess this one used, what is the charge? What is fixed layer? What is mobile layer? What is zeta potential? Or what is the colloidal solution here if NaOH is added? Anyhow, these are important questions. Okay, this is the preparation of colloidal solution using peptization process. So next one is in this dispersion only, third method. Is it clear? Peptization, very important one. So next, preparation of gold sol. So in that notes I given just like one line only, because I given complete synopsis notes, not theory notes. But this Bredik's arc method, preparation of gold sol, this is important long answer also. Okay. So with diagram you have to learn for theory. What I given notes, that is the entrance notes. Just one line I mentioned, not more. Okay. So Bredik's arc method. Preparation of gold salt. This is used for the preparation of gold salt, silver salt, platinum salt, like this. Not sodium and potassium. They are highly electropositive. They are not prepared by using Bredik's arc method. This is used for the preparation of noble metals specially. Okay. Gold salt. Gold salt is prepared by using Bredik's arc method. It is an electrical process. Anyhow, here also we are converting large to colloidal size. So how to prepare this? So first take beaker. Okay. In this dilute potassium hydroxide solution. So what is the stabilizer used in the Bredik's arc method? Given there is a potassium hydroxide. Take that dilute potassium hydroxide solution. Okay. 2 gold rods. Insert 2 gold rods. These are gold rods. Connect these 2 gold rods to battery. Okay. Now just take one beaker, in that potassium hydroxide, very dilute solution, potassium hydroxide solution, then insert 2 gold rods connected to induction coil. Then nearly 10,000 volts current we have to pass. When electric arc strikes between these 2 gold rods, when electric arc strikes between these 2 gold rods, 10,000 volts current we are passing. Immediately this gold dissolves, nothing but it changes to vapor. Gold, that is the solid rods we are taking. Then when electric arc strikes between these 2 gold rods, gold vapor particles will form. So in this solution, gold vapor particles are formed. Now this gaseous gold particles raises surface. During this journey, here cooling takes place. Now gold particles are formed. Now these gold particles, nothing but like solid particles are formed. Now these particles are surrounded by OH minus ions. When electric arc strikes between 2 gold rods, then gold vaporizes, gold vapors are formed. But these gold vapor raises surface, then here cooling takes place, again gold solid particles are formed. Small gold solid particles are formed. Now these particles surrounded by OH minus ions, surrounded by OH minus ions, nothing but that forms one protective layer. That gold particle surrounded by OH minus means that is a protective layer. Now it changes to colloidal sized particles. So in this medium, colloidal sized gold particles are formed. So what is the solution formed? Colloidal solution. So it is the preparation of gold colloidal solution using Brady's arc method. Thinking that how it is very small given but long answer. That is the long answer only, Brady's arc method. So how to prepare means with neat diagram, okay, you have to write. So here take one beaker, in that dilute a potassium hydroxide solution, then insert 2 gold rods, connect to induction coil, and when electric arc strikes between these 2 gold rods, nearly 10,000 volts current, so immediately gold vaporizes, rods vaporizes, changes to gold vapor particles. These vapor particles rises to surface, then that gaseous particles changes to cooling takes place, condenses, changes to solid. Immediately each particle surrounded by one protective layer, that protective layer is OH minus, then it changes to colloidal solution. That is the preparation of gold colloidal solution using Brady's arc method. Now this gold sol is negative sol or positive sol? Surrounded by OH minus, nothing but it is a negative sol. So metallic metal salts, anyone given direct we can answer that is a negative sol. Hydroxides, anyone given answer is a positive sol. Hydroxides are positive salts. Metal oxides, hydrated metal oxides are positive salts. Metal salts given there is a negative salt. Now this is a negative salt, gold salt preparation. Anyhow, what happened here? Gold rod, nothing but we are converting into precipitate to colloidal solution, larger one to smaller one. Okay, this is a dispersion process. So first method is a dispersion method. So second one is a condensation. So what we did here, 2 methods we are taking, dispersion method and condensation method. In dispersion, 3 methods we are following. What are the 3 methods? One is a grinding process for graphite preparation, and next one is a second one. First one is a grinding process and second one is a peptization process, and third one is a Brady's arc method. These are the 3 methods in dispersion method. So next one is a condensation. Here we are following physical methods and also chemical methods. What are the major physical methods? Chemical methods. So what are the major physical methods for the preparation of colloidal solutions? Nothing but here we are converting small particles to colloidal size particles. Here large to colloidal size. Now small to colloidal size particles. Physical methods. What are these physical methods? Just to take vapors, condense the vapors, then cooling takes place. So while cooling particles comes closure, nothing but that changes to colloidal size particle. Nothing but what is the process here? In physical method, condensation of vapor. Nothing is there, vapors, collect vapors and condense that, cool that, all these particles condenses, that time close packing takes place, then it changes to colloidal sized particles. That process is condensation of vapor. Generally zinc, cadmium, these salts are prepared by using condensation of vapors. Okay. Otherwise, excessive cooling. Nothing but condensation, excessive cooling. Here chloroform. Chloroform colloidal solution, that is prepared by using excessive cooling process. And here one important process, that is a solvent exchange. No chemical reactions, that's why it is considered as a physical method only. Solvent exchange. Nothing but in one solvent is added, it forms a true solution. If you exchange the solvent, any other solvent added in that solvent, it can changes to nothing but association takes place. Because of association, it changes to colloidal solution. In one solvent, it forms a true solution. In other solvent, it can changes to association. Nothing but colloidal solution. So by exchanging the solvent also we can prepare the colloidal solution. Indigo dye, that is prepared by using solvent exchange process. Just we have to exchange the solvent. For example, in water it forms a true solution. Exchange the solvent benzene. In benzene it forms a colloidal solution. Okay, association takes place. So by exchanging solvent also we can prepare. This is not important, but anyhow 3 physical methods. And by dissociation also we can prepare. So condensation of vapors, excessive cooling, solvent exchange. These are physical methods. So very important chemical methods. So what are the different chemical methods used? Here also one simple trick there in chemical methods, easy to identify. So chemical methods, what are the chemical methods used for the preparation of colloidal solution? The first one is the double decomposition process. Given is double decomposition or not, easily we can identify this compound decomposes, another compound also decomposes. To decompose that reaction is the double decomposition process. But very simple identification is sulfide sol anywhere given, direct answer is that is the double decomposition process. So here arsenic oxide AS2O3, this is fixed example in all the materials. AS2O3 it is treated with H2S. AS2O3 decomposition takes place, H2S decomposition also takes place. Then it changes to AS2S3. AS means there is a arsenic oxide reacts with hydrogen sulfide. The product obtained is the arsenic sulfide plus H2O. Now it is a colloidal solution. Sulfide salts are prepared by double decomposition process. Fixed, that is sulfide salts are prepared by double decomposition process. For example, you take cadmium oxide. It is treated with H2S. Then the product obtained is cadmium sulfide plus H2O. Now this cadmium sulfide is a colloidal solution. So sulfide salts are prepared by double decomposition process. Otherwise we can take these halides also, nothing but KiAgNO3. Both decompose now. So AgNO3. Instead of Ki, now I am using KCl or NaCl. Iodide or chloride or bromide. This one decomposes, then it changes to colloidal solution. Now this is also double decomposition process. So easy to identify, 2 compounds they will give, 2 decompose changes to one new compound. Like that given, definitely the question is that is the double decomposition process. Okay. So sulfide salts are prepared by double decomposition process. This we can use for the preparation of a sulfide salts. And next one is the oxidation process. Oxidation reduction anyhow direct we can identify. For example, given is so second method, oxidation method. By using oxidation, how to prepare the colloidal solutions? Given is H2S. It is treated with chlorine, sulfur salt formed and HCl. Now this is oxidation or reduction method. So sulfur salts are prepared by oxidation or reduction, like that question given. Just check it. Here -2. -2 changes to 0. -2 to 0 increase in oxidation number. The process is oxidation. By oxidation only this salt formed. So using oxidation method we can prepare the sulfur salt. So fixed example, that is a sulfur salts are prepared by, given answer is a oxidation method. Sulfide salts are prepared by double decomposition process. Gold, silver, these salts are prepared by, in that dispersion method, Bredik's arc method. Hydroxide salts are prepared by, in that method, peptization process. Peptization process, no. And come to this, another example, H2S plus bromine. The product is sulfur salt and HBr. And very important repeated example here, H2S plus HNO3. Sulfur salt plus NO2 plus H2O. Okay, here we are getting sulfur salt reacts with nitric acid. Any oxidizing agent we can use, oxidation takes place, hydrogen sulfide oxidizes to sulfur. Okay, hydrogen sulfide is oxidized to sulfur. Otherwise we can use direct oxygen or simply sulfur dioxide. This also we can use. Then it changes to sulfur plus H2O. So using any oxidizing agent, we are converting this hydrogen sulfide to sulfur. So I given all the examples, total examples you have to practice. So preparation of sulfur salt is example for oxidation method. So next one is a reduction method. Third method, reduction. Now here AuCl3 in the presence of formaldehyde, HCHO, formaldehyde, AuCl3 changes to Au salt. Okay. Now it is oxidation or reduction. What happened? Check it. This is a +3. +3 changed to 0. +3 to 0 means the process is a reduction. So gold salt is prepared by reduction method. Or AgNO3 we convert it to, using tannic acid we can convert Ag salt. This is called Argisol. Argisol, this is the gold salt. Now here what happened? +1, this changes to 0, nothing but decrease in oxidation number. So the process is a reduction process. So gold salt, silver salts are prepared by reduction process. Now the given question is the gold salt and silver salts are prepared by Brady's arc method, oxidation method, reduction method, hydrolysis method or double decomposition method, like this given. So what are the answers here? Brady's arc method is correct answer and also reduction method. So these two are prepared by using Brady's arc method and also reduction method. So reduction method is used for the preparation of gold silver salts. Okay. So next one is the hydrolysis process. Hydrolysis, just reaction with water. Okay. FeCl3, anyhow we prepared there also for peptization. FeCl3 is treated with water, the product boiling with water, then product obtained is a FeOH thrice. This is the hydroxide salts. So any hydroxide salt given, the process is a hydrolysis. So ferric hydroxide salt is prepared by using Brady's arc method, peptization method, hydrolysis method and oxidation method, like this given. What are the correct options here? Peptization process and also hydrolysis process. Gold and silver salts are prepared by Brady's arc method and also reduction method. Sulfide salts are prepared by double decomposition process. Sulfur salts are prepared by oxidation process. Sulfur salts are prepared by oxidation process. And graphite salt is prepared by grinding process. Chloroform salt is prepared by excessive cooling process. Indigo salts are prepared by solvent exchange process. I given all these examples in that notes. So it is the preparation of a colloidal solution. Just one simple chart is there. That is the preparation of, I given like chart only, preparation of colloidal solutions. So two types. There is the dispersion method and also condensation method. In dispersion method, grinding process, peptization process and Brady's arc method, and in condensation physical methods and also chemical methods. In physical methods, solvent exchange method or excessive cooling method or condensation of direct vapors. Okay. And in chemical methods, oxidation process, reduction process, hydrolysis process, double decomposition process. Fixed examples are there. Just one time you practice, then you can answer the questions. Okay. This is about preparation of colloidal solutions. So next, colloidal solutions prepared. Now how to purify these colloidal solutions? Purification. Now purification of colloids. How to purify these colloids? First to take that impure colloidal solution, nothing but that colloidal solution contains some crystalloids. Crystalloids means the true solution particles, solute particles that we have to remove. So to remove that we are using dialysis process. Hemodialysis, well known, where artificial kidney for the purification of blood, hemodialysis process, kidney patients. So dialysis. So here what is the principle involved? What happens here? In this dialysis process, there is a purification of colloidal solution. Purification of blood is a colloidal solution? No. So purification of blood. So purification of colloidal solution. So how to purify? Take one parchment bag. Semi-permeable membrane. Okay, this is a semi-permeable parchment bag. First fill this bag with a colloidal solution. Okay, and close this one. Then keep this bag in one beaker. Neat diagram. So very simple method. Just take the given colloidal solution in parchment bag. Okay. Keep that bag in one beaker. In that beaker we are using water. And we should maintain here continuous flow of water. Okay. So water enters like this. Now what happens? This is a semi-permeable membrane. Not like osmosis, a slight difference is there. Osmosis means only solvent moves out, solvent comes out or solute comes out from semipermeable membrane, solvent. Here it is the dialysis, here semipermeable membrane, how we are using, the pore size is very small. This pore size is very small. Nothing but colloidal solutions are separated by using ultrafiltration. Otherwise ultrafiltration also we can use. Ultrafiltration means just take filter paper. Filter paper pore size is large. Because of large pore size, true solution particles passes out. Colloidal solution particles also passes out. If ultrafilter paper used, what is the difference between filter paper and ultrafilter paper? Just pore size. Ultrafilter paper means normal filter paper we have to soak in that colloidal solution and formaldehyde just to increase the hardness. Formaldehyde we have to add. So which chemical is used for the preparation of ultrafilter paper? Given there is a formaldehyde. Then dry that becomes a ultrafilter paper. What happens here? That pore size decreases. If pore size is large, true solution particles comes out and colloidal solution particles also comes out. We can't separate colloidal solutions and true solutions. Here separation, purification means just we have to remove the crystalloids, nothing but true solution particles, that is solute and excess solvent is that also. So normal filter paper use both passes out. That's why we have to use a ultra filter paper. Nothing but its pore size is small. So here true solution particles comes out, but colloidal solution particles not comes out. Then remaining in that is a colloidal solution. So using simple method means ultra filtration, we can purify this colloidal solution. So perfect purification means like this we have to do. Here also it is like ultrafiltration. One semi-permeable membrane, parchment membrane we are using. Its pore size is small. Then if it is placed in running water, then here water moving here. Along with this, from this true solution particles comes out. True solution particles because size is small comes out. Along this water, this true solution particles also moving. Okay. Along with water, the true solution particles also we are moving. Not only here, anywhere we can take that outlet, one inlet and one outlet we are using here, running water, okay. Along with this water, true solution particles passes out through the semi-permeable membrane. So these true solution particles and water wash out. Now here, if the same process we are conducting long time, then what happens? Osmosis. This solvent present in this, nothing but dispersion medium, the dispersion medium also comes out. Dialysis process, short time only we have to do that. Long time we are doing, what happens? This we are using for the purification of colloidal solution. Nothing but in colloidal solution some crystalloids are there. We are removing those crystalloids. Just take one parchment bag in that colloidal solution. Keep that parchment bag in running water. So along with water, the crystalloid size is very small. So they comes out through the small pores parchment membrane. It allows the crystalloids and little solvent also. Now crystalloids comes out, washed out along with this water. Okay. Long time we are conducting, all crystalloids are washed out. Then here colloidal particles, nothing but dispersion phase is there, dispersion medium also there. Now it is the semi-permeable membrane. This dispersion medium also comes out. If dispersion medium also coming out, what is the remaining there? Only dispersion phase, nothing but precipitation takes place, coagulation takes place. That's why we should not conduct excessive dialysis, just a dialysis process for short time. Then all crystalloids comes out. Then pure colloidal solution we are getting in this parchment bag. Very simple process. Just take one parchment bag and colloidal solution in that. Keep that in one beaker and maintain that water, continuous flow of water. Then along with that water, because it is a semi-permeable, complete true solution particles comes out, we can remove the true solution particles. Okay. But excessive dialysis conducted, then what happens? Precipitation takes place. Okay. Anyhow, this is very slow process. To speed up that much patience is difficult. To speed up that, what we have to do? Just we are using. So what we are using here? We are passing electric current. If electrolytic dialysis, electric dialysis, just pass electrolysis, nothing but electric current. Then it speeds up the process. Process is similar, everything is similar. Just to speed up the process, we are passing electric current. That process is the electrolytic dialysis, electric dialysis, simple dialysis and electric dialysis. Okay, just electrolysis process, pass current, then it speeds up the process. So how to purify these colloidal solutions? Using ultrafilter paper we can purify, or using ultracentrifugation. but excessive centrifugation precipitation takes place and dialysis and electrolytic dialysis process. These are different methods used for the purification of colloidal solutions. Just dialysis, electrolytic dialysis, the difference is just to speed up the process we are passing electric current, but principle is similar. Crystalloids comes out through the parchment membrane. Okay, this is about preparation and purification. So next, important properties of colloidal solutions. What are the properties of colloids? So AS2O3 plus H2S gives AS2S3 sol. This method is AS2O3 plus H2S gives AS2S3 sol. This method is oxidation, reduction or double decomposition, or it is a dialysis. The dialysis is for purification only, not for preparation. That is the double decomposition process. Gold sol is prepared by Redox arc method and also reduction process or oxidation process. Reduction process. Gold sol is negative sol or positive sol? Gold sol is a negative sol. And hydroxide salts are negative or positive? Hydroxide salts are positive salts. Sulfide salts are prepared by using double decomposition, oxidation or reduction. Double decomposition. Sulfur salts are prepared by using the process is oxidation process. In dialysis, what is the principle involved? Semi-permeable, both solute and solvent passes out through the semi-permeable membrane. Nothing but separation of true solution particles, colloidal solutions particles from true solution particles. Crystalloids we are removing. Crystalloids we are removing. So in artificial kidney, what is the principle involved? Given there is a hemodialysis. Hemodialysis is the principle involved. Nothing but the principle is dialysis only. That process is a hemodialysis. Nothing but purification of blood. Okay, purification of blood. So next one is the properties. And what is the chemical used for the preparation of ultrafilter paper? The chemical, it is soaked in formaldehyde. So properties of colloidal solutions. So what are the important properties? So the first one is the Brownian moment. Brownian moment, Tyndall effect, electrophoresis, cataphoresis, anaphoresis and electroosmosis. These are different properties. And color and colloidal nothing but some colligative properties. What is the change in colligative properties of colloidal solutions? Properties of colloidal solutions. So the first one is the Brownian moment. So what is this Brownian moment? Nothing is there. Based on these two important questions, we can expect colloidal solution. Dispersion medium, and here dispersion phase particles are there. Solute and solvent. Okay, solute and solvent. Now these particles moves randomly. Now here the collision of dispersion medium particles, dispersion medium particle with the dispersion phase particle takes place. Because of this collision of dispersion medium with dispersion phase, now it moves like this. How it is moving? This type of movement. Nothing but there is a zigzag movement. Zigzag, they are not moving in a straight line, not in a particular order. Moving, that is like zigzag. Zigzag movement of colloidal particle is called Brownian movement. So Brownian movement means there is a zigzag movement of colloidal particles. What is the reason for the zigzag movement? This dispersion medium collide with the dispersion phase. So what are the two important questions? One is what is Brownian movement? Given there is a zigzag movement of dispersion phase particles or colloidal solution particles, there is the Brownian movement. Reason for this Brownian moment, dispersion medium particle collide with a dispersion phase. If the given option is a dispersion phase particle collide with dispersion medium, wrong answer. Medium collide with the phase, that's why this phase particles are moving in a zigzag manner. So zigzag movement of dispersion phase particles or colloidal solution particles, that movement is called Brownian moment. Reason for this, collision of dispersion medium with a dispersion phase. Collision of dispersion medium with dispersion phase. So what is the importance of this Brownian momentum? It maintains the stability. Otherwise, if there is no collisions, there is no zigzag momentum, all these particles settles down, that forms like precipitate. So dispersion phase and medium separates from one another. So it maintains the stability. The importance of Brownian moment, because of this Brownian moment only, that colloidal solution is stable. Otherwise milk, sometime if you kept that milk, total fat should settle down and upper layer is water, bottom layer is fat. Like that not happens. Why not happens? The reason is Brownian movement. The colloidal particles always moves randomly. Zigzag movement takes place. That movement is called Brownian movement. That's it. That is the first property, Brownian movement. So next property is a Tyndall effect. What is this Tyndall effect? What is the reason for Tyndall effect? What are the applications of Tyndall effect? How to identify that? That is in nothing but remaining properties. Next class. Okay. So until then, take care.